Amazing. Welcome back to Street Talk Unplugged. Today I'm here with Professor Julian Togelius from New York University and also Professor Ken Stanley from OpenAI on co-interviewer duty. Can you believe it? This is the first time that we've done anything like this. I'm really, really excited. It's a good time to be alive, actually. So, Julian, can you introduce yourself first, and then we'll hand over to Ken to do the same.
Yeah. Hi, everyone. I'm Julian Togelius at New York University, where I'm an associate professor in one of our several computer science departments. And I'm also a co-founder of Model.ai, which does AI for games. And well, I do a lot of AI for games and open-ended learning and things like this. I guess we'll dig deeper into this.
Indeed. And Ken?
I'm Ken Stanley, and right now I'm leading the open-endedness team at OpenAI. And I know that Julian and I have a lot of common interests, so I'm very looking forward to this chance to talk.
Amazing. Well, let's start proceedings here then. So, Julian, you've said that you think that games are a good test bed for AI models. And by extension, actually, that if an AGI were capable of performing well on games, then it would be job done to a certain extent. So what's your take, Julian?
Right. Yeah, I said this thing that video games are great for training general AI back when people didn't really believe in it. People thought that board games are great and board games capture what's great about human intelligence and so on. And then it turned out that it wasn't really enough because people went ahead and achieved human-like performance in these board games with amazing systems like Deep Blue, AlphaGo, and so on. And still, these systems weren't really capable of doing anything else than just playing these board games. And I was saying that, well, we have all these video games. And in fact, they have this very, very, very wide design space. They test a lot of different cognitive skills. In fact, game designers, when they design games, they're essentially exploring the space of cognitive adaptation that we humans have, and the sort of mapping out cognitive skills by finding designs that test our ways of thinking in new ways. And that's what I was saying, that if we tried to create agents that could play games, not just one simple game, but games in general, video games in general in particular, then we'd probably be pretty close to what we could call AGI.
Fascinating. But it gets into a really interesting philosophical discussion, though, because the task-specific skill is quite crystallized. So I don't think anyone thinks that that's intelligence.
I think that you are right, that when you put the question that way, task-specific skill is not intelligence, people will agree with you. But I also think that this is implicitly what people think. They see someone doing a lot of things that look intelligent, and then they're like, yeah, this person is intelligent. Yes, but at the core, intelligence is about being able to rapidly build on what you know and learning to do something more on top of this, something that sort of builds on this and is a new capability. And this is why, if I fire up Steam and download a random game and start to play it, I will probably learn to play this at a decent level relatively fast because I played a bunch of games. I used to say that I play a lot of games, but not as many as I should, given that I lead a game innovation lab and stuff. But someone who does not have experience playing a lot of video games will not be able to do that. So in a sense, my somewhat general, my intelligence in this sphere of certain video game design conventions has become higher by playing all these games. Now, of course, you could try to ask, what about my intelligence in general? So my answer is that I don't believe in that. Every notion of intelligence is always relative to some domain.
Well, yeah, I mean, games are such a wide spectrum of possibilities that it probably, in my view, encompasses like a lot of what we think of as sort of outside of games. I mean, there are games where you have social aspects, and you're building a life inside the game, and it's not necessarily entirely what you would do in your whole life, but it captures a lot of what intelligence applies to. And so it does seem to me, and I know that I overlap with Julian a lot here, with that games have a lot of potential for learning high-level intelligence, or even near the human level. But I'm curious, Julian, like your current thinking on how well this is playing out with the game industry, because I know that like maybe we had a dream that like there's such a great synergy here between these two opportunities, like gaming and AI, that like there's going to be this great partnership going forward. Like it would be really cool for the games too, probably, if they had really good AI, right? And it's good for the AI if there's really interesting, sophisticated games. And I think it turned out to be maybe a lot more complicated, but I'm curious what you think the current status of that is.
So it was a beautiful dream, wasn't it? Yeah. So it's a dream we shared about like being able to develop state-of-the-art AI, and this would somehow improve games. And yeah, I spent the last 15 years trying to, partly trying to do that in different ways. And most recently through co-founding Model.ai, which is an attempt to bring things from research to where it would actually fit into the game development pipeline. And it's hard. The parts where it's helping most is in game testing. So agents that can help you play through aspects of game to test them, and certain parts of procedural content generation, generating levels in specific cases. But the dream that some of us on this call had once upon a time, that, hey, you'll be able to learn generally intelligent agents and these would make the game better. That is way more complicated because games are not designed for that. I like to say that most game designs we have build on templates that were made before we had any kind of useful AI. So we had to design RPGs and so role-playing games, first-person shooters, MMOs, puzzle games, anything, racing games, around the lack of artificial intelligence. And now that's the game design conventions. So I think that it is really interesting. Both Ken and I have worked on this, trying to design new games around the availability of artificial intelligence. I think this is very, very, very fascinating. It's very hard. It's the kind of work which you can't get academic research money for because this is not research, and that the game industry doesn't necessarily support because A, they don't support research easily. B, these are just very strange games. But it's true that just like taking an existing game design, putting some kind of really clever agent in there is not going to make the game better. In most cases, it's just going to make it worse.
Yeah, I mean, the game industry clearly has some risk aversion to like
Yes.
exotic experimental things, and I mean, it's understandable. Like, I mean, it's not like some kind of scandal or something like that. But yet, yeah, I mean, what is the way around that risk aversion? I'm curious because it's frustrating from the like the opportunistic side. Like you see, like, oh, this things could really work together well and do something interesting. Like, why is there no room to have a little playground where we could try things like that?
I think this will have to come from individual sort of AI practitioners / game designers that are well versed enough in what modern AI can do and have a game design sensibilities and do these things, put them out on Steam without any expectations of actually making money. And this will point the way forward. And if this sounds rough and unfair, that is how indie game development is. It is kind of rough and unfair, and most people don't make money out of it. But it's if I was running a large video game developer and I had to put $100 million into my next game production, knowing that if it failed, we would be out of business. I would also be kind of conservative, so I get it. It's. And it's also the problem that building a modern game with all the modern production values is extremely expensive, simply. So,
but I mean, but these big tech companies, I mean, they have like not game industry companies, but other big tech companies. They have research wings and things like this. Like,
right.
why is that so hard for the game industry? To have labs or something. Like, it seemed like it'd be worth the investment. Like, let's see what could happen. Make some little games that might send a point to the future in some way.
Some have, but on a very small scale. Like both Ubisoft has LaForge, EA has Seed. These are smaller outfits, and they tend to be focused on how they can support existing game productions that build on existing game design conventions in specific roles, such as game testing, which we also do in Model AI, procedural animation, and so on. There's a bit of they did some interesting. The guys at EA Seed, they actually did do some interesting procedural generation work, and they sort of and they publish it, and it's pretty nice. I like it, but it's very much supporting the existing paradigms, and I agree. You need to sort of, if you want interesting AI to come out there, and AI that makes a path towards makes progress towards AGI, whatever AGI is, then you really need to sort of rethink these conventions and sort of build things around, like, what if you take a very simple, concrete example: dialogue trees in role-playing games. No one thought that the way we should have conversations with agents is by navigating down the dialogue trees. That was like basically designed out of necessity, because we didn't have any useful NLP technology back in the 80s, and we didn't have the hardware to run it on. We didn't have the processing, we didn't have RAM or whatever. And that became a design convention that stuck, and this is now how you do it. So people like Nick Walton, who made AI Dungeon, his company, I forgot what his company is called, but anyway, the AI Dungeon company, they are courageously trying to define new paradigms for that. Yeah, I hope they succeed. But that's like one of these venture-backed things. It doesn't come out of the big game studios, because that's not how they think.
So I want to come back a little bit to this notion of intelligence, because I've got a few questions around this, and I want to get to your ideas on super intelligence and the intelligence explosion as well. But folks like Pei Wang, and again, by the way, the idea of having a formalism at all is something that Ken and I have spoken about. So you could formalize it in respect of an agent taking in percepts and having an internal state and performing actions in an environment. I don't know if that's too much of a formalism or not. And then you could assess what an intelligence is in respect of if it does the right things in respect of an input, or if it does it in the right way because it has the right state and stuff like that. So like with that framing, what would an intelligence be for you? For example, do you think AlphaZero is intelligent?
My intuitive answer is no, because it's way too domain specific. Then reminding myself that I just said that everything is kind of domain specific, which I deeply believe. My revised answer would be not particularly. AlphaZero is extremely limited to acting on one particular kind of problem. It can be retrained, but even the sort of domains in which it can be retrained is very, very small, and the retraining itself is very, very expensive. So I don't think it can be said to be intelligent in any meaningful sense. No. I do think that formalisms can be inspirational sometimes. I like Shane Legg and Marcus Hutter's universal intelligence definition, partly because I like to point out all the ways you can disagree with it. But it has inspired us. It inspired us when we built the general video game AI competition, for example. But I don't think that any formalism will ever sort of capture everything we mean by intelligence. In general, I think there are too many physicists in this field. Physicists are really strange because they live in a world where formalisms make sense, and where like the mathematics in a sense, is the reality. And I think that kind of thinking is currently very much overvalued within artificial intelligence, because these are not the kind of entities we deal with. And the sort of the things we're trying to capture will somehow vanish if we formalize them that much. So back to your question, what do I call unintelligence? I think it's a kind of a misposed question. Intelligence is a word we apply to various organisms in various circumstances, and it's always domain specific, and even the boundaries of the organism matters a lot. This being said, I use the word intelligence a lot, so I would associate it more with being able to survive in a large variety of environments, or like being able to act seemingly rational in large variety of environments with only short training time or short learning time.
Yeah, I agree that the efficiency thing is important, because even though AIXI, or the universal intelligence idea, is interesting, it's one of these appeals to infinity, in the sense that it's kind of saying, well, if you could do absolutely anything, then this is what it might look like. And there's this thing called the McCorduck effect as well, which is every time that, we produce something which seems intelligence, there's a chorus of people that say that's not really intelligent. And there's this parable of the elephant problem as well, as you say, that we're all describing this thing in a particular way, but we're excluding many important aspects of the thing. And I think one of the problems here is that, like many complex phenomena, intelligence is an emergent thing, and it makes it impossible to describe it succinctly.
Yeah, it's also like a folk psychological concept. It doesn't necessarily have a true definition. We could come up with a very limited definition that would be mathematically beautiful and logically consistent, but that definition might not be useful.
Well, how do you like the term AGI, or artificial general intelligence? Is that helpful?
It's bullshit.
What? Again, why is it bullshit?
No, because the main reason I dislike artificial general intelligence as a term, and as the existence of which as the premise of a discussion, is because it gets tied up with a super intelligence argument, which I think is extreme bullshit, harmful bullshit. But let's start with artificial general intelligence. What I do like about it is the spirit that we need to go beyond coming up with solutions to individual tasks. And I think that's inspirational again, and it has sort of guided a lot of interesting work on trying on domain adaptation and generalization in reinforcement learning, something that I've been working on quite a bit recently, for example. And I know you have, Ken, for example, as well, and open-ended learning. But so there's a nice impetus behind it. And I like that it sort of, puts a spotlight on, like, we can go beyond these very, very narrow things that are dominated AI for so long. But the general artificial general intelligence is always, you need to always put it into like, into quotes, basically. Artificial, quote, general, unquote, intelligence. Because how general can it really be? It's always domain specific in some sense. This is often what you sort of need to figure out. Helps, basically, when you turn the question on its head, so what is natural general intelligence? Then most people would basically say that, well, that's what humans have. But then humans are also very domain specific. In terms of individual humans, I live here in New York City in a nice, cushy Western environment where I do like complicated things like taking the subway to work and talking to my PhD students all day and writing papers. Most of the tasks that humans solve around the world, I have no idea what to do with it. I'm completely worthless as smelting iron or harvesting wheat, or even like sort of adjudicating adjudicating conflicts about like land use or taxes, or I'm not saying I'm particularly stupid. I'm a little bit stupid, but I'm not particularly stupid. It's just that I know a very small amount of things. Could I relearn and do the other things? Yes, I could probably become a tax lawyer, but that would take me 5 years or something. So how could you reasonably say that I'm generally intelligent in that sense? Then, of course, like even all of humanity, everything we know and every environment we can survive in, that's extremely small compared to all the tasks that you could possibly do in the universe and all the environments that could possibly exist or even do exist in the universe. So we have like a lack of generality in many, many ways. So I don't think artificial general intelligence can ever exist because there is no natural general intelligence, and I don't see a reason why there would be any.
I agree. So a few things to unpack there. First of all, I think Ben Goertzel invented the term AGI, and he was exasperated with the notion that all the AI that we're working on now is narrow AI. And I think basically he meant it wasn't flexible. But I agree with you.
Yeah, I think it was Shane Legg.
Oh, okay. Maybe I'm wrong on that.
But could be a discussion about it.
Yeah, indeed. But so I agree with you that all intelligence is in the context of something in a particular domain, in a particular environment. There's no such thing as completely general intelligence. I agree with that. But there's also this notion, I know you worked a bit with Eugen Schmidhuber, and he had this notion of a Gödel machine, a self-referential universal problem solver making provably optimal self-improvements. And I know you've spoken about Good's informal remarks on an intelligence explosion through self-improving techniques, and this is actually what a lot of the the Nick Bostrom style people talk about. This notion that intelligence will improve itself. I personally don't think AGI means self-improving intelligence, but Francois Chollet wrote a wonderful article about this, talking about the rate-limiting steps in the environment that would actually stop any self-improvement or limit any self-improvement. But what are your thoughts on that?
No. So I agree with. I think Francois Chollet's article is really good there. And my thoughts on this is that it sort of follows from that there isn't really any natural general intelligence. It sort of follows that there is. It's sort of hard to imagine what a self-improving artificial general intelligence would be. Not as in I can't imagine because I have no imagination, but I'm not sure it even seems self-consistent, the idea. So the idea, so if you try to think out what it would mean to be a self-improving artificial general intelligence, then you would need to be able to improve yourself by rewriting your own code. That's complicated because how would something understand its own code well enough, and still keep that in representation in its mind? But let's say, for instance, that you could do that. Well, you only get so far by rewriting your own code. You still need to augment all the code that this builds on, because you have networking code, your operating system code, and probably the hardware that it builds on. To augment the hardware, you need an extremely huge global supply chain. You need to sort of generate and design better chips. So you need to have better machines that can build them. So you need better lasers, and you need better mining for the component that goes into these, and so on. You need better logistics to transport things and so on. Basically, what being sort of, self-improving at an unlimited scale, what it means is that you sort of need to improve the whole world economy. So I would say that the only reasonable way you could think about a self-improving organism would be if you saw the civilization as we know it as an organism that is self-improving. Now, this I could buy. This might actually be the case. So there is a version of the superintelligence argument, which I believe may be true to some extent, but in that version, all 7 billion of us humans are kind of part of the machinery of the self-improving thing. And then you can see people saying, aha, well, there is an AGI in there somehow that controls all of this. Like, sits in a box somewhere in a server room and controls all of us like marionettes or something. To which I would say that sounds dangerously like all kinds of disproven and unlikely conspiracy theories. That's just not how the world and its fundamentally distributed decision making actually works. So the AGI, so the superintelligence argument, it's in almost all versions almost ridiculous, except the version where you talk about it on civilization scale. But even then, it's really hard to figure out what's the agent.
What do you think, though? Like, if you put aside the jargon and like these different terminologies, like, what do you think we should be aspiring towards? It's like, what is the North Star, Holy Grail thing?
Now that's a really interesting question. I think we should aspire towards gradual generalization, gradually more general capabilities. And it's fine to come up with somewhat contrived and weird benchmarks for this. So maybe maybe coming from actual use cases. I like these ideas of working on like developing embodied robots that could basically be home nurses and take care of a person who is bedridden in every conceivable way, such as, cooking dinner, cleaning the carpets, watering the plants, taking care of the pets, and whatever you may need to do in a home. And that's great because that is a very, very wide range of skills you need to do there. Even though all the skills, please note, all the skills here are the kind of skills that we selected or created as a human civilization. Why is opening a door is a hard skill for a robot, but it's an easier skill than it should be because we made all the doors so that we humans could easily open them. So it's still very domain limited, but it's like a reasonable challenge. Now, so that's a good challenge, and there are many challenges like that. Personally, I want an AI that can play every game on the App Store or Steam library reasonably well. And I think that would be a very great achievement, and it would teach us a lot. This is not how I write things in grant funding proposals because other people might roll their eyes like, why would anyone want to do that? How is this helping humanity? I think it's helping humanity by teaching us a lot about how to build, quote, intelligent, unquote, machines. Another big vision is that I want to build environments that we can call them games, we can call them entertainment environments, experience environments that are self-creating, that you can go into a simulated open world and you can walk in any direction and the game will present you with experiences, would present you with things. Say you're playing Grand Theft Auto and you sort of walk in any direction, you get like new cities, new and people in there with driving cars you never seen before, and they have like relationships you never heard about before. They have like new narratives, and this is all sort of there to basically serve you in a sense that the system is trying to probe what you like, what you find interesting, what experiences you have not yet had, but it thinks you would actually like to have. And this would be interesting because it would advance the state of the art in both like building worlds and building narratives, building game mechanics, building all these things. But it would also very much it would very much sort of advance the state of the art in systems that understand humans and look at what we do and what we say and try to get inside their minds and model us.
Yeah, it's interesting because there's kind of two sides to what you're describing. I think one is kind of a more mechanical operations, like the nurse who takes care of the patient or something like that. So basically has certain articulation skills that it needs to learn, like to get the food or to give a bath or something like that. And then there's like very creative, like, creating a world or something like that. Where like that's like not just good for games. You could have like, artificial intelligence like literally participating in culture. And I guess, like making things for us in the real world too. So I'm curious about your feeling about those two things. Is that like, do you think they're related to each other, or that, is one more important to you than the other?
Yeah, I mean, there's a difference between important for humanity and important for me.
Yeah.
I'll have to, and all hubris aside, that I have to recognize this distinction. I think I am personally, I mean, I come from a family of artists, and this is how I grew up. I never grew up with I was never taught to always think about the best for humanity. I grew up with people who literally painted for a living, and when they couldn't make a living out of painting, they would sort of take a day job and sort of make money from that somehow. So all the way grumbling about wanting to get back to the real work. I'm very interested in machines and methods that can create and that can create together with us, both autonomously in response to us and how we behave, but also together with us. I think the history of art is very much a history of technological development, because art has driven so much development in ways of manipulating colors and materials and representing reality and so on. And I think that and new art styles have also been driven not only by trying to depict what people see or sort of depict or narrate what people see around themselves, but also new technologies that make this art possible, from new methods for painting and sculpting and colors and so on, to new methods of writing and sort of and of course digital art like games and so on. So I'm very interested in that because I think it's intrinsically interesting, and this is what contributes to our culture in a sense. It helps us understand ourselves and gives us better and richer lives. Now, I forgot what was the original question.
I mean, I think you answered it pretty well, but I guess I was curious about the seeming kind of dichotomy between the very practical nurse robot and then create a level which is so open ended, and there's so many creative aspects to that.
Oh,
just how those unify together.
I think there are several ways to unify together. On the somewhat abstract level, all problem solving is creative, and everyone, basically, I think I can safely say that everyone practices some creativity in their life. Even if what you're doing is being a home care nurse, you will find problems that you need to solve creatively. This wasn't in the book, how am I going to deal with that? The cat sleeps on the medicines or whatever, then you have to figure out something about that. But there's also a more down to earth or closer to the actual current research frontier way, which is that, and I know you've been working a lot with that, Ken, for example, that we can use creativity to create problems that our agents can learn to solve. So generating levels, it's great in itself, but it's also great because it can help us test and retrain reinforcement learning agents, for example. So something that has been discovered by a bunch of people over the last few years is that deep reinforcement learning tends to overfit in a pretty bad way. Reinforcement learning agents tend to not only be overfitted to a particular game, they can only play that game, nothing else, but also to a particular level, or particular levels in a particular sequence, and a particular sort of, screen resolution, angle, sort of frame rate, everything, every little part. And you change any part of this, and you get random behavior and for all the thoughts you just had about I saw these deep neural networks playing these Atari games. It's really smart. Look, it can play Pong or Montezuma's Revenge or something, and then sort of you change just a tiny bit of thing and you see it collapse. Now you wonder, how could you learn something slightly more general, slightly more general game playing skills? And I think part of that a very important part of that is generating parts of the game as you go along. Maybe not only the level, but also the rules of the game and the graphical representation. And you can also vary a ton of different things. So in a sense, this is like the data augmentation, which people have been talking about and practicing in machine learning for a very, very long time, but taken to new limits, how to sort of do this. And one thing that I am very interested in at the moment, and I know you've been working on Ken before, is exactly what kind of levels do we need to generate? What's interesting in generating here? For example, do we want to generate levels that discriminate well between different agents? Do we want to generate levels that are hard? How hard? Do you want to generate levels that have a particular set of challenges in a particular order? What are interesting points to vary, and so on? So these are things I'm working on pretty much as we speak. But yeah, and this is one way. So to get back to the question, this is one way how very mundane concerns of solving particular tasks intersects with creativity and automatic creativity.
I really wanted to unpack exactly what we mean by things like creativity and open-endedness and subjectivity and ambiguity and all of that. But let's just quickly do the reinforcement learning thing now, because I want to eventually contrast that to some of the open-ended methods that Ken introduced me to, by the way. Absolutely opened my eyes when I discovered Ken's book and research. But you've spoken about the overfitting of deep reinforcement learning. I actually made a video on my other channel about Alex Erpan's article, Deep Reinforcement Learning Doesn't Work Yet. You probably read that one before. But But you know, you said that, is it because we're training on the testing set? Is it because the training set is small and homogeneous? Is it because our models are too large? Is it because the input representation favors learning specific strategies or something else? And you were just saying, well, if only we could generate data as we go along. And I'm thinking it's because neural networks are locality sensitive hashing tables. So why do you think these reinforcement learning algorithms are, you said memorizing the environment?
Because it's the easy thing to do. I agree with you that neural networks in many instances work pretty much like, and specifically if we talk about reinforcement learning, they often work more or less like locality sensitive hashing. But why do they do this? Because that's the easy thing to learn. It's a path of least resistance in a sense. This actually plays into a bigger critique of is it good that gradient descent is such a dominant paradigm? Because currently gradient descent is the dominant paradigm. I've written before, but I've had some troubles articulating as well as I would want to about how I think that the implied greediness is not very good for learning the kind of complex representations that we probably need to learn. I'm not saying it's impossible, but I think that's, I use a lot of modern deep learning in what I do based on gradient descent. I come originally more from the evolutionary computation side of things. And I still think that the path of making larger stochastic changes and letting them play out and be evaluated over a longer time has the advantage that you can learn things that gradient descent would struggle to learn, because the gradient descent would always be pushed around by the data points, essentially. Now, so this is one reason. In general, reinforcement learning methods that we know and love, that we know and use currently, are extremely prone to just taking the simplest way out, the simplest way to sort of, get a good performance. And this is not a controversial point of view. This is generally accepted. And knowing this, the problem is, the extreme variation of the conditions that you want to get through to procedural generation is there basically because you need to explicitly vary everything you don't want reinforcement learning to learn to use as a crutch. In a sense, the relevant question is not really why does it overfit, why does it learn these very specific solutions, is how can you make it ever do anything else? It's because it doesn't come naturally, like to gradient algorithm. You will naturally sort of move towards the simplest solution in sight, and that is almost always some extreme form of overfitting. Your question was also about like if there are other reasons for this, right?
Well, maybe we'll just quickly meditate on that. So I guess I'm trying to tease apart in my mind, because one aspect of it is the shortcut rule, which is that you get exactly what you optimize for at the cost of everything else. And these models are trained monolithically with a single objective. And Ken opened my eyes to this idea of, a system with a panoply of objectives has no objective at all. But I'm still thinking in my mind that the way all neural network architectures work is you've got the MLP backend, which is the hash table, and then there's a whole bunch of architectures for doing the diffusion of information with successive equivariant layers. So you're kind of spreading the information out into those buckets. So with that in mind, how could it do anything other than memorize the environments? I mean, maybe we should bring in the NetHack challenge. So apparently the reason why that didn't work for reinforcement learning and did work for symbolic methods is because it wasn't possible to memorize the environment because the environment was different every time.
Yeah. When I saw the NetHack challenge, I was like, this is a great challenge. I had one of my PhD students was really interested in working on it, and that we haven't really put any real effort into that yet. We may still do, but I immediately thought that no way we're going to get to see reinforcement learning doing well on this. Not anytime soon. It's not, the environment is also not represented in a way that the neural network would like. It's naturally not such a representation. And of course, the variation makes it really hard to do. So yes, I sort of, this is very much a symbolic friendly environment, which is why it's good. I hope that people keep working on it. Now Ken is about to say that, actually my team just solved it.
Wish I could say that. Actually, I was going to ask you guys, because I wasn't sure if, I only read a little bit about that, but my understanding was that neither approach did well. Like the symbolic approach just was better, but that wasn't exactly good, or it was far from good. So it's just sort of like, we don't really, is that true? Is that pretty much accurate? Like there's really not a good approach.
It was, again, I think it comes back to what we were saying at the beginning about what is intelligence. So the symbolic approach basically was a representation of the game, as if you'd coded it up, with classes and methods and so on. So is that really intelligent?
If you can represent, if you can take a game and basically represent it so well, so you can keep it in memory and try executing things. You basically use the game as its own forward model. This is almost always the best way to play it. It's just that many games are so computation demanding that you can't easily do that. But yeah, with our Mario AI challenge back in 2009, when we put it online, we thought that this is going to be a great challenge and people are going to, work hard on this and so on. And then Robin Baumgarten of Imperial College basically solved it within the first few weeks by doing exactly this, using the game as its own representation, and then just planning. And classic AI methods like planning combined with sort of a past simulation are just like extremely good in many cases. The question is, can you use the environment as its own representation?
So could we contrast this, because we were just getting to the contrast between the monolithic reinforcement learning approaches where there's a single reward versus, and Ken would say that's keeping all of your eggs in one basket, versus approaches that utilize diversity preservation. So what do we get there?
I think the quality diversity paradigm is extremely powerful and will eventually eat all of AI.
Great.
More or less. So in quality diversity, you may be doing an optimization task. You may also not be doing an optimization task, but crucially, you're exploring a space and trying to find diversity along some measures. In original knowledge search, you simply have a distance measure. In Math-Elites, you have several behavioral descriptors, or you can call them. These days we often call them measures or metrics. This is terminological confusion. And you want to find solutions that are just like evenly spread out along these measures. And you may also want to find solutions that are good along those measures. In almost every problem where you're trying to optimize something, you're not actually looking for the one best solution. You're looking for a large amount of different solutions that differ along some dimensions you care about. And then you want to pick. Even in cases where you just want one solution, you probably want to have a large amount of diversity in the process to make sure you actually find the best solution. And I think this realization has yet to diffuse widely into the AI and machine learning community. It's not there yet, but I think it's crucially we see use cases for it everywhere. We see use cases for it in, like, if you're trying to learn a policy to play a game, well, you probably want many different policies, and you want to choose among them, or you want to combine them in some sense, and you want to be able to adaptively, rapidly switch from one to another or something. If you want, like, content generators, you probably want several different, so you can get like a wide variety of content styles produced. If you want models that help you predict who to hire, you probably want different ones so you can explore the trade-offs and so on. For like almost every case where you can imagine you want machine learning optimization, you probably want to use a quality diversity method instead. Luckily, there's a lot of development going on in sort of taking the core ideas behind things like knowledge distraction, Math-Elites, and combining them with, because these are essentially at the core, they're like classic evolutionary algorithms, but working with diversity as the main thing to do. But combining them with modern gradient-based methods to sort of get the best of both worlds. We developed something called the covariance matrix rotation Math-Elites that is like a modern evolution strategy in the Math-Elite structure. And we're just like seeing that this is like the default thing we apply to basically everything. But every problem we see, first of all, now.
You previously commented about the contrast between gradient-based and, well, it's not necessarily what you'd call evolutionary, but just kind of like knocking something out of its zone, like intentionally, which tends to be not what gradients do. Do you think that, like, in light of what you just said about quality diversity, that is that a relevant distinction still, do you think? Like, or is it like it doesn't really matter what the underlying kind of optimization method is. You can just use a different gradient, let's say, to push it one way or another. Because you're talking about using, gradient methods with these quality diversity algorithms.
Yeah. So gradient methods obviously have many advantages. In particular, they're efficient. But I do think, and I think you can combine them with quality diversity. You can make quality diversity that are partially gradient-based or completely gradient-based in many ways. But they sort of, but I do think there's still an advantage to sort of doing the undirected mutation at various steps. Like the learning algorithms of the future will almost certainly take place or sort of operate on multiple different scales. Some scale where you're doing large undirected mutation, and some scale where you're doing gradient descent search, and you also throughout this trying to maintain some kind of diversity. And you may have one or zero or many objectives, and you may have the number of like dimensions of variance that you can it might be important. New dimensions may be collapse as you search. New dimensions may appear as you search. And this may be partially interactive with human users. You may point out that, hey, the difference between this thing over here and this thing over there isn't this is an interesting difference. Keep that in mind as you continue searching, for example. But I think that just like undirected mutation definitely will play a role in there. So this waiting for all these like insights to coalesce. I think there's also movement from the other side, so to speak, from the side of people who haven't yet sort of been converted to the quality and diversity religion. In particular, when it comes to reinforcement learning, finding leaks and sort of, finding sets or pools of teams of collaborators or like adversaries. Like AlphaStar, in AlphaStars, I think it's called leaks. You have like leaks of different collaborators, then a new agent needs to be, or a different adversaries, a new agent needs to be tested against all of these, for example. This, by the way, are classic ideas from co-evolution, competitive co-evolution, collaborative co-evolution that have sort of been rediscovered over the time. So I think that many streams of thoughts are sort of, pushing towards this realization.
I recommend folks read Ken's book as well. So when I read Ken's book and I learned all about this notion of deception in search spaces and the false compass, that absolutely changed my perception on everything, because I now realize that, you need to keep your options open. But I wanted to just touch on one other thing as well. So I'm quite interested in this notion of empiricism versus rationalism. And one of our guests, Walid Sabah, he rails against deep learning because he cites Chomsky's poverty of stimulus argument, which is basically that, kids must have native cognitive templates because they can't possibly learn enough by the time they're 4 years old. But not only that, there's also a notion that you've raised. So if you look at Einstein's theory of relativity, for example, it's kind of provable that you can't derive that from data. You need to have some kind of higher level cognition. And then you made a really interesting move, which I didn't quite understand. So I hope you can explain it now. You kind of said that with these evolutionary type algorithms, that's akin to the rationalist type thinking as opposed to the empiricist type thinking. Don't understand that.
No, I'm not sure I understand it myself, but I still think there's something there. I think that gradient descent in gradient descent, you're fundamentally pushed around by the data. Data points appear, and the causality is that the data point pushes your hypothesis, if you want to use that terminology, or your model in some direction. And you're very much similar to how in classical empiricism, the sense data are supposed to literally make impressions on your mind. This is what's happening in gradient descent based deep learning. Evolutionary computation is based on the random change in its most pure form. Now, and the random change that happens at another level. It happens kind of at the hypothesis level. You're changing a random hypothesis, and then you're testing it. The fitness evaluation is the testing of your hypothesis. Now, what people have raised against this, I think Jeff Clune at some point basically said, or just as you said, Tim, like, I don't understand this really, because hypothesis formation isn't random. That is correct. Hypothesis formation isn't typically random. Sometimes it is. Sometimes people are like, this doesn't make sense, so let's try it anyway. That's my favorite kind of science. This is a stupid idea, so let's try it. But it points to that there are other things. Evolutionary computation, you can have very many different forms of mutation in there. And like throughout the history of evolutionary computation, people have tried all kinds of different things. For example, what very often happens in real life hypothesis formation is pattern matching. Like, I have seen another theory that looks like this. So I'm going to take the pattern of this theory and overlay it on what I think in this field. And now I have a new hypothesis, and then I'll go out and do this. So this could be like a form of mutation that does pattern matching. And this is entirely viable. And I think this is the kind of a more rationalist conception of search.
Yeah.
So say you're sort of, you have, this gets harder to sort of apply intuitively to the neural network search space because, neural network weights don't really mean anything, but you could imagine that you have like a particular sort of, say you're sort of evolving a decision tree. You may know that there's a particular kind of tree structure you've seen in another decision tree. This hypothesis formed this way, and you may want to sort of just apply this to some part of your own tree, and this becomes a hypothesis. Then you try this by fitness testing it. And it's not a perfect analogy, but I do think there's something there, and it helps underscore what are the limitations of gradient descent, like pure gradient descent search. I'm much more certain of like the connection between, or I feel much better about the connection between classic empiricism and gradient descent than I am at the connection between rationalism or critical rationalism and evolution. But I think there's a way of making them meet somehow.
You started off by talking about, you actually invoked randomness. And it's not random, is it? And this is something that Ken's work fascinates me as well, because Ken has this notion of interestingness. And the problem is when we define creativity, and we were getting back to that definition problem, there is no definition, right? What do we mean when we talk about open-endedness and creativity? And I think Ken was trying to formalize it in the sense of accumulating information. Like in natural evolution, there's an arrow of complexity. Would you agree with a formalism like that, or how would you define it?
Is there an arrow of complexity?
Can you? So in your abandoning objectives paper, I think you said that you were one of the first researchers in the ML world to almost validate, or at least take seriously, this idea in biology that there's this arrow of complexity of increasing information in natural evolution.
Yeah, I think the argument is about this idea that as opposed to following a gradient towards improving performance, which you normally do in machine learning, we could be trying to just increase the amount of information in the system, which is a different kind of, I guess you could call gradient, but it's a different kind of thing that you'd be searching for. And so I guess you could look at divergent searches or novelty-driven searches or interestingness-driven searches or things like this as effectively doing that. Like they basically increase information in some way. And if you look at evolution over eons, I guess you could see that it's uncovering more information about. So the question is about what? I guess about nature in some sense, like about all the things you can do. You can fly, like you can walk, you can ambulate, you can move through water, like you can do photosynthesis. You can think, like all these things. So like this is like an index of possibilities opened up by physics, and they're being kind of unveiled because of this kind of search that isn't necessarily objectively driven. And so that's kind of an arrow of complexity. I think that kind of sense of like let's get more and more abilities cataloged in this like archive in some way. And it's both population and individual. So like as an individual, it's like we know all the planets in the solar system and things like this. Like this is definitely like an accumulation of information relative to our ancestors. So something like that.
Yeah. In that sense, that makes a lot of sense. And I do think that, as we work in open-ended systems, one thing that's really crucial here is that we think about the environment as the thing that's developing in an open-ended system isn't just the agent, which is like a kind of sort of somewhat arbitrarily sort of defined entity, but like the whole ecosystem. Because the reason why we can do things that seem so intelligent is that we built this whole civilization that enables us to do all these things that seem so intelligent. And we have like this extreme freedom of action. So branching factor of a human living in modern world is insane. And the reason we could build this complicated civilization is the extreme complexity of life on Earth, which then depended on previous life on Earth and so on. So in that sense, and that you sort of implicitly creating an archive of complexity through all the living things, that makes a lot of sense. Now, is there I guess the thing I reacted to is that, is there also an area of complexity in terms of individual organisms, having acknowledged that organisms is somewhat arbitrary boundary, but and that's less certain. Are we more complex? And are we more complex than other creatures? Are we more complex than our ancestors, our grandfathers, or whatever? That's not obvious. Maybe not. Is it necessarily true? Probably not. But yeah. Maybe what this points to is how important it is to think of intelligence and cognitive capability on a population level.
Well, I'm curious, like when you like getting to individuals, just to understand your viewpoint. Like, I think some lineages, I agree that it's pretty ambiguous. Like, has complexity increased or not? Like, we could debate about it. But in the human lineage, like, you're saying that it's not clear, for example, that like humans are more complex than flatworms, or is that? Because like to me, it seems like it's pretty reasonable to think that. But would you contest that?
Well, I'm sure I could find some measure by which it is false. There's like yeast genome is like extremely complex. And then you sort of, then you look at it, still just yeast, and I like bread and everything, but still, it's, so that, but that's kind of a stupid measure of complexity. So would I contest it? I would qualify it. I would say, like, we are certainly more complex in dimensions we care about than basically all our ancestors. Are there other measures of complexity by which we are not more complex and maybe worse?
Mhm.
Probably. Can I put them right now? No, because that's because
Yeah.
I'm interested in kind of inhuman kind of things. Maybe this is a silly objection. I was just, to me, it makes more sense that there's an area of complexity on a population or ecosystem level, which I think there definitely is. And I'm a little bit more confused on the individual organism level.
Yeah, I get it. I mean,
yeah.
somehow it relates to the issue of like the definition of complexity. It's somewhat, because it's not well defined here, and so I'm just going with sort of intuitive. Like, I feel more complex than a flatworm, but yeah, it's true. If you play with the definition, it gets confusing. But I don't know if that's that useful to play with it.
No, not true. I think it underscores that I'm also looking for complexity. I'm also looking when I sort of, if we create like an agent that either it sort of plays a game or generate a game level to look at things I typically do, I'm also looking for complexity. I want it to do things that I couldn't have predicted it would do.
Yeah.
I want it to wow. That's the kind of complexity I'm looking for. But in many cases, when we're looking at general intelligence, I feel on an intellectual level, though I'm not sure I practice it, we should looking more at the population or ecosystem level. How can you find like a wide variety of organisms with that work together to create something complex?
I think that's really interesting, because like it is true that a lot of AI today, or modern machine learning, is focused on an individual. Like, there's just one thing that's getting better, but this notion of a population, there's a lot of power in it, I think. And yeah, I wonder if you could say a little more, like what's the difference? Like, why you think a population adds something important than just optimizing one thing?
I think a population in particular, when it's heterogeneous, when it's not all the same, is interesting because the different in a population or an ecosystem, because the different organisms create the conditions for each other to be intelligent. So intelligence is always relative to a domain, and all organisms we know of are like adapted to a particular domain where we sort of, we are intelligent because of the world we build. Now, if you have an ecosystem of different organisms behaving in some environment, they can sort of create that for each other. I don't know how to do this. And I don't know whether anyone really has good ideas of how to do this. There's a long history of A-life experiments like Terra, Navida, and so on. And there's a bunch of like more graphical A-life worlds and so on. These all are kind of primitive in what they actually were able to do. And kind of unsophisticated in their methods. Now someone would probably come and sort of hit me over the head with like, actually here's this fantastic experiment that they'll take off. But I think that's a big sort of untapped potential. In particular, as we work on open-ended learning, which is definitely one of my big interests. We're still looking at like, here's one single environment going about in one single agent in one single environment. And there's like a population of agents, but they're all trying to solve the same task, or like, they all have the same affordances and so on. I think there's a wide open field of things we have not explored out there, or not explored in any kind of depth.
I think one thing that really fascinates me is a lot of the interesting phenomena happens at a different level, a different rung of the emergence ladder, if that makes sense. And I'm starting to see this everywhere. Like even at work, I'm building a code review platform, and at the low level, the metrics are obvious. I know Ken talks about the tyranny of metrics, by the way, but it's how many code reviews has an engineer done? How many customer engineers do I have? It's easy. And then I start going up the levels of abstraction. I'm talking to the senior leaders, and now I'm starting to use much more abstract language like vertical information flows and trust and engineering culture. And all of a sudden, it's impossible for me to quantify it. And if I do, I'm making it up. And it's the same thing. You're talking about these population scale phenomena that happen now. So I've got all of these intelligent agents. They're doing things. And I can try because now I've got a meta optimization problem, right? So I want to encourage interesting phenomena in the emergent scale. So I might say, well, this type of thing is interesting. I want more of that. But I'm reaching because I don't know how to describe it.
I don't know either. I mean, one way to phrase this is that doing the kind of research we're kind of outlining here, it might be hard to get it into NeurIPS because you don't necessarily easily have a graph where the number goes up and the benchmark to beat. Not saying that every paper in NeurIPS is like this, but hey, let's say that this is the norm, right?
I mean, I think one other characteristic maybe you can point to that kind of separates like population from just individual is sort of specialization versus generalization. Like I think population-driven algorithms sort of implicitly are more about specialization a lot of the time. Because like each member of the population, you want them to be doing some different thing. So they're kind of becoming specialists, but I think there's a huge amount of generalization snobbery kind of within machine learning. Like we're looking for the ultimate generalist all the time. It's like get it to do all the tasks you can possibly do and then throw more in, and the data set just gets bigger, and we're all very impressed with that. And the population implies, I feel like something's in spirit different, because it's more just like, actually, I want to see a lot of different things and like hyper specializations to all kinds of exotic things that like probably the generalist won't do because it's basically all it cares about is being general. Yeah. What do you think? Do you think that's also maybe part of why populations are appealing?
That's true. And this comes down to like the focus on like the particular level of abstraction or the level of agency that we have. This is the level of the agent, and this is what we care about. So you want to generalize at the level of agent, but maybe you should generalize at the level of the ecosystem or population. If one interesting thing is like, if we look at like very boring so-called machine learning, boring but useful machine learning, the stuff that keeps winning all the Kaggle competitions, especially with structured data, is ensemble methods such as XGBoost. And interestingly, they solve problems by splitting and not having a single agent or single model, having a bunch of different models, enforcing diversity through a very different way than the quantity diversity methods, by changing data set and then combining them together. So in a sense, it is the population that is solving the problem. So it's a convergent line of thinking.
Julian, it's such an honor. I've really, really enjoyed this conversation. Thank you so much. And Ken as well.
Yeah.
Oh, me too. This
Likewise.
was great.
Yeah, this was great.
Thanks
Thank you.
to both of you.
Thank you for giving me the opportunity to be here.